الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmina.
Okay, hello everyone. Assalamu alaikum. Hope you are doing well. Hope you are بصحة جيدة و everyone is safe. معكم مرة أخرى طه رحاه, expert machine learning at Geeks and the main engineer at Dipeco, in a new session on the ManaDD series. Today, inshallah, we are going to be talking about how to deploy deep learning model using FastAPI and Docker. So it's pretty much a new topic that we never talked about here on our sessions. We are going to be trying to leverage the theoretical side, the theoretical part from conception, theory, etc., into production, aka deployment of our model. So for the agenda of today's session, we're going to be trying to define what is production environment, aka defining the state of AI nowadays, why we even now a lot of people are talking about production. Remember when we talked on a past session about the MLOps, it was we mentioned that like nowadays most of the companies are switching into MLOps because they are no more, or they're trying now to get their models into their production ready environment. So most people talk about it. Let's discover the ML tech stack or the deep learning tech stack on this. What are the types of model conception? The considerations that we need to take when we say that I want to deploy a model. There are some criteria that we need to follow in order to be able to deploy a model. So that's the idea. Then we are going to be trying to go as a workflow on a small project, which is like being implemented using FastAPI and Docker. So we try just like simply deploy an ML model, not a deep learning model, using FastAPI and Docker. You are going to see that it's easy. I'm going to share with you a framework that is called Katana. It's like a very good framework that allows you to use Docker and FastAPI without it does make it easy for you to code using FastAPI and Docker together inside one framework. So it's going to be a little bit interesting on it. Then we can take a Q&A as always. Okay, so let's start. I will be running out, as I always mention, I'm going to be running out into the definition of why even we need to talk about production. So I'm going to be going step by step. First of all, AI is everywhere, or as they say nowadays, AI is the next electricity, or is the electricity of the future. As you can see nowadays, everyone or every company is switching to electricity, coming from cars to maybe soon plants to any objects that they do work on diesel or fuel. They are now switching to electricity. So electricity is going to be we're going to be so dependent on electricity. It's exactly the same thing about AI. Many fields, or let's say all the fields on the future are going to be dependent on AI. Going from recommendation systems like Netflix is doing on the background AI, Amazon Prime, or any other watching or streaming platform. On search, like Google is using a lot of AI on its search motor. Fraud detection, where we can detect fraud of credit cards or any other sort of fraud detection, is also behind it. There is AI assistants. Obviously, it's named AI. So like the Cortana from Microsoft, like Siri from Apple, Google Assistant, etc., etc. On many fields that like nowadays AI is like going inside those fields. But one field which is I'm going to be leading the I'm going to be leading the example on it, which is the retail. Let's see this video. I beg you all know, guys, about you all know about Amazon Go. So let me let's watch quickly together this video.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So, how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
Okay, so I will be taking the Amazon Go example. Sorry.
4 years ago, we started to wonder.
Right. Okay, so I'll be taking the Amazon Go example as a leading example for this session and for the part 2 upcoming session, inshallah, since like 1 hour is not going to be enough to cover FastAPI with Docker. But I'm going to be taking always the Amazon Go example since it's for me, one of the best examples to showcase the importance or the gap between research or between theory and production. Amazon Go is a solution of retail being implemented in retail, and it uses many algorithms as they stated on the video. They are using computer vision, they are using fraud detection, they are using like some embedded systems algorithms. They are using many algorithms. They do have a big pipeline of AI algorithms. So it's why it's a good example, because most of people think about production or about deployment about one model, but mostly in most of the real world cases, it's not about one model. It's about a series of models. It's about like a whole pipeline where the model 1, the output of model 1 is going to be the input of model 2, then model 2 is going to be communication with model 4, etc., etc. So basically, it's a bunch of models, and here where the things gets so much complicated. So here where we need like tools of management, communication management, etc., etc. Mostly Docker and FastAPI are not going to be doing this, but to start simple, to start small, let's do it with FastAPI and Docker. Then we can scale up into some new technologies like KeyServe, MLflow, integrate MLflow to manage the experiments, etc., etc. So like we have a bunch of technologies that we can use in order to solve this problem. In this schema from McKinsey & Company, I'm showing that the impact or the value of AI solutions by 2030 is going to be 30 trillion USD. And as you can see here on the schema, mostly the biggest value or the biggest impact is going to be on retail. Retail is leading the market. And when I say retail, solutions like Amazon Go already being implemented in 2017, they started. So imagine in 2030, mostly we are going to be seeing a lot of Amazon Go's like solutions in the whole world. So retail is leading here, leading the market. Then next, we have transport and logistics and travels. Also, this is a big area where we can use deploy production AI in production on it. Mostly also the healthcare system. So imagine in 2030 you are going to be you have you are sick, you head to the emergencies, then like you are dealing only with robots. So from check-in, from registration to like doctor, etc., etc., everything is going to be managed by AI, managed by assistant robots. So like the whole world is going to be changing to using AI. And I'm not stating, I know many of you guys know this, but I'm not stating this to state the importance of AI, no, but to state the importance of production. We're going to be needing the production, we're going to be needing people that's going to be doing the deployment of those models. We have people that they could or they can build this type of models, but we don't have yet many people that they can deploy this model and maintain those models and let those models available on the production scale. So mostly, if you ever heard about DevOps principles, that we are going to be talking about them, by the way. But the principle says that like we need to have a solution that is maintainable, available, consistent, and like other criteria that we need to take into consideration. So all of those needs to be like mirrored into our AI solution, which is not easy because that AI it's not like 100% reliable. We still have it's not like 100% mature, so our solutions could have issues, could have related bugs, etc., etc. So that's why we need to manage this. So the question is from where to start. Sorry, from where to start, or what should I learn? Which technology? You know that the ML tech stack nowadays is so big. It's like so messy. So we have many technologies that they can go from TensorFlow. They can go from TensorFlow to Keras. They can go also from PyTorch to scikit-learn, etc., etc. So basically, the tech stack is a mess here and needs to be maintained. Or the question of all the beginners, beginner friendly people, they ask, what technology should I learn? Should I learn first? Then what's the next one? What's the third, etc., etc. To sum this up, I will tell you that like we need to learn at least one technology among those four pipelines. Or as you know, the life cycle of any ML model or any AI project is data. First of all, data. So we need to learn at least the technology on the data processing pipeline. We can state Airflow or its equivalent Google Cloud Composer. We can use Kafka. We can use any of those those Hive also, any of those tools. So at least one of them inside data processing pipeline. For the machine learning components, mostly we don't have so much choices. So we have TensorFlow or AKA Keras and PyTorch. So either learn one of them or both of them. So it doesn't matter. For MLOps, we have plenty of tools, plenty of solutions that they could be used to do MLOps. So I'm going to skip this. Not going to mention a lot of them, but this is a whole topic, a whole topic to talk about. Then to scale, for the scaling model, scaling and MLOps are two like related sides. But what I wanted to state is at least start with learning one technology inside one of those pipelines. So either one technology on data processing, one technology on machine learning, one technology on MLOps. Do not like get confused with all of those messy texts, messy libraries and messy tools that they could diverge you from your initial goal, which is learning how to deploy the model. So for our project, or for Katana, they choose to use like some simple tools. Docker for scaling. Basically, here the heart is Docker. So Docker for scaling. Hugging Face transformers for like getting the models, or as an API to get the models. PyTorch also for developing your own models. VS Code for coding. Scikit-learn for ML. So transformers for deep learning and scikit-learn for machine learning, and some other tools for just like the management of code and the good for the good intent of the good structure of the project. So next question here is, how should you get about deploying deep learning or machine learning models? Which like this is where most of people get stuck, and this is where like not get stuck, but they do ignore it. So when they deploy the model and when it's ready to be used by the end user or by the end client, it's not available and it could not be done easily. First of all is the ML or the machine learning design considerations. So as I was saying, like when we develop software, either on web development or either on mobile development or any other development field, we do have some design considerations or sub-conception considerations. Same thing for machine learning. We do have design principles that we need to follow. We need to understand more the use case where our model is going to be developed, but it's going to be used by who, how much time, how many prediction requests we're expecting. So all of those, they do enter on the ML design considerations, and they do not enter to the job of the ML engineer or the ML scientist who is developing the model. So when developing the model, we don't care about the model, the deployment of it. We don't care about where it's going to be used and when and how many requests we're expecting. We just care about accuracy, precision, about those metrics. But like when we want to develop, we want to deploy, sorry, we don't, those metrics mean nothing at the first step. So those metrics are meaningless since like we have the model, but how we can make this model deployable and usable on production. Sometimes the model is very hard to make on production. Sometimes you use a complex architecture that could not be deployable unless you change the whole architecture or you change the whole mess. So that's here the idea, and that's here the considerations that many companies or many organizations are trying to fix, trying to implement into their pipeline. So first question, how the model is going to be used. How the model is going to be used includes a lot of criteria that needs to be followed, that needs to be taken into consideration, which is the first one, which is the latency. When I say latency, I mean time. So how fast can you get the prediction? Which means like if I am a user, I'm using the Amazon Go. Amazon Go uses computer vision. So the latency is how fast or what's the so like how fast or what's the time that I'm going to be waiting for in order to get that prediction. So like if I pick a cupcake from the row on Amazon Go store, I pick the cupcake, how much time I'm going to be waiting in order to that cupcake to be added into my wallet or to be added into my basket. So that's the latency. So here the model needs to check what product I picked, then check the code bar, then insert them or send the data into my mobile phone. So this time is called latency. The bigger the latency is, the worse the model is or the worse the deployment is. So latency needs always to be small, needs to be the model, which means the model needs to be fast on prediction time. And this is a problem because not all the models, like yes, we do have models that they do great. They do great things. Like here, this image is from DALI. I don't know if you know DALI from OpenAI. This image was generated from DALI. You just enter a text, and then DALI is going to be generating an image for you. The latency of DALI is very small. I don't have the exact number, but it's pretty much not that remarkable by the end user. Even if the model is big, so the model is doing a lot great things. Sometimes we do have models that they do also great things, but their prediction time or their prediction latency is very huge, which makes them undeployable or ready to be used in production environments. Secondly is the throughput, which is like how many requests I'm getting per second, or how many inputs I'm given to the model per second. So this has a relation with batch processing, with batch prediction. Also, we call it batch prediction. So this also needs to be taken into consideration because it's relatable to latency. Because if I have 100 users at one time, all the 100 users are like inputting a picture of the cupcake, and I'm expecting from the model to telling me or to classify what object is this. Is this a cupcake? Is it a juice? Is it what is it? So here also we need to pay attention to how many requests we are getting, and then we like input this to the architecture of the model, or we can take it into consideration when building the model. Secondly are the types of model conception. consumption. Now we have many types of how we can consume our models. First, it can be real time, so the model can be deployed real time, like the case of Amazon Go. The model is real time, and we are consuming it on a real time basis. There is also batch processing, where we like group a batch of inputs, then we send the batch to the model, then we get batch responses. So this is batch processed consumption. It can be also offline edge, where we inject the model into an edge device or into an Android phone, like what TF-Lite is doing nowadays, or like what they are doing on the on some embedded systems like the cars, like drones, etc. So they are injecting the deep learning model, the whole deep learning model, to be able to make predictions offline. So it's not online here, it's offline, which means like on the hardware, the model is going to be receiving the request, and locally it's going to be processed, and the response is going to be sent also locally. That's what we call offline edge conception. Also, it can be online edge conception, where we develop mobile apps, then we connect them with the machine learning model through internet. So that's the normal case where most people work on it. So it does require only internet connection here. Let's take a real world example. Why latency matters. So many of you can see why latency matters and why I'm talking a lot about latency. Let's take two examples of Google and Booking. Google took as latency of between 100 and 400 milliseconds, and she like during the research they remarked that a latency of like 400 milliseconds, which is like less than 1 second, it reduces the search amount of between 0.2 until 0.6%. That was in 2009. So imagine now in 2022, the amount of searches that they are being done every second on Google. So imagine if only a latency of 400 millisecond is causing 0.6% of reducing on the number of searches. It's going to be it's huge. Same example for Booking. Booking said that like a 30% increase in the latency cost is causing them or in latency it's costing them or causing them 0.5 reducing of 0.5% of the conversion rate. When I say conversion rate, for many ad based companies like Booking, it means they are losing money. So losing money for a company, that's their nightmare. Also, according to a research that was conducted by Google, they said that 53% of phone users will leave a page that takes more than 3 seconds to load. If you are a phone user, and you are using either your browser or an application, and that application uses an AI model, something like this, so that uses just like twice to open a page. If it takes more than 3 seconds, which means like you are going to be leaving. So if we have 100 user, 53, we are going to be losing 53 of them, which is more than half of our users, which is huge. That's why we need to pay attention to latency, and we need to take it as the first criteria or the first thing to consider when deploying the model. DevOps. Now let's talk about DevOps. Yeah. So to summarize, we talked about latency, model consumption, and the criteria that we need to take into consideration in order to make a good deployment or to make a good production-ready model. Now we're going to be talking about a little bit about the DevOps standards to mix them between DevOps, MLOps, so DevOps for software development and ML, Ops for ML, for machine learning things. Back in 2015, as you can see, Etsy, or I don't know if you know the company Etsy. Etsy deployed 50 times per day, which means Etsy did the new deployment 50 times per day. So which means they changed it on their production website, on their production solution 50 times a day. Netflix did 1,000 change on the production platform per day. AWS back in 2015 did one change every 11.7 seconds, which is like those are huge numbers. So imagine like a company doing 1000 change per day, or doing a change every 11.7 seconds. So there is like they are making those changes on the production, not on the development side. So like imagine that now I'm opening YouTube, and YouTube is changing on the production every 11.7 second. This is like those are so big numbers, and this is needs to be taken into consideration. And what the relation between this and ML is that on machine learning, I don't need I cannot like let my solution down in order to update the model, or in order to retrain the model, or in order to correct to change the loss function, or to correct the way that the model is acting. I cannot like make changes directly on it. I need to keep the production running, and in parallel I need to be changing or updating the model in a way that like the end user not going to be getting this or not going to be feeling this. That's where DevOps was being invented. So DevOps is the fact that like I have the production, but I have the team working on updating what's on the production, then just like merging between the production and what's being updated, and not changing directly on the production. That's for ML. They like just like not in 2015, but just on 2019 and 2020, people were deploying the model, then making change on the production directly, making changes on the model on the production directly, which is this against DevOps. That's why MLOps was implemented, to follow the guidelines of DevOps, to follow like those guidelines, and to make sure that everything is good on it. I'm going to skip this slide, just like to make it quicker to go to FastAPI and Docker. But the idea here is that I beg all of you guys know that before training, we are looking about data, we are collecting it, cleaning it, and like making data version, etc. Then during the training, we are just like trying to understand which model, which consumption type our model is doing, what is the latency, try to measure it, what is the space, what is the approach that's going to be working on the deployment, then train it, test it, deploy it, monitor it, and retrain it online or offline based on the approach that we choose. So basically, those are the steps, or this is the life cycle that a magic model passes from. Now let's summarize the design considerations that we talked about. So we are going to be following 5 design considerations, the most important ones. First one is the availability. The model or the solution, the AI-based solution, needs to be available all the time. It needs to be like there is no downtime. So in deployment, there is a technical term, which is downtime, which means like the time where the application is not available to the user. Our AI solution needs to have as much lowest downtime that we can ever get. It needs to be reliable, which means like same thing. It needs to be always available. It needs to be like when we need it on, or when there is a lot of requests, lots of traffic, etc. It needs to be working. Needs to be available. Maintainable, which means that like if something happens, if an error shows, if a bug shows, we can maintain. We can maintain it, and we can make changes on it. Not like just a solution that could not ever be changed or being updated. It needs to be adaptable, which means that the AI solution needs to adapt to the data or the environment where data is coming from. And also it needs to be adaptable to changes of environment, changes of techniques, changes of usability, changes of use cases. So this is adaptable. And finally, it needs to be consistent, which means like the performance needs to be good, the predictions need to be accurate, and like the end user needs to get their information or their data or the response in a good manner. So an example for the Amazon Go example. For availability means that like the Amazon Go algorithm need to be serving all predictions from the Europe, Middle East Africa region. So that's the idea here of availability. Reliability, which means that latency do not need to exceed 10 milliseconds. So 10 milliseconds is the maximum of latency that we could get. It needs to be it needs to support more than 2 million predictions per second, since like 2 million prediction, which means 2 million requests, which means like people are taking objects, then returning them, then they are taking new objects on another part. So many predictions need to be managed per second. It needs to be also easy to maintain, and it could be updated with low to no downtime. So either low downtime or no downtime at all, which doesn't exist obviously, but it could be 99.99% of downtime, of no downtime. Then obviously it needs to be consistent, which means the performance slash the prediction needs to be good. Yeah. Next one, the model lifecycle. So we have data preparation, as I was mentioning. We have the training, then we have the deployment, then we have the MLOps. Deployment and MLOps are on the same part. Today we are going to be covering the deployment using the Katana tool. The Katana is, as I told you, a mix between FastAPI and Docker, which are like two main tools that are very widely used on the deployment of models. Let's first start by introducing FastAPI. For those who never heard about FastAPI, FastAPI is a modern, as they define it, modern, fast web framework for building APIs with Python 3.6 or greater, based on standard Python type hints. So if you know Python, if you master Python, you can build an API very, very quickly using FastAPI framework. It's like very easy to build an API using pure Python. As like you can write very quickly an API that can handle requests, make some treatment, or make some processing, and then send back the response. Why Fast API? What are the key features of Fast API? Obviously, by its name, it's fast. So because it's to be honest fast. It's a high performance API because it's working on the top of Node.js and Go. And whoever knows that Go is always taking the first rank on concurrency and high performance requests. It's fast to code since everyone now can write code using Python, so it's easily to write a fast API rather than using Java or using the other language or other frameworks. Fewer bugs since it's managed. It does gives us, since it's a framework. It's not only a library, so it does allows us or give us most of the architecture structure functions that needs to or could be used in order to build an API. It's easy. It's short, robust, and it follows the standards based on JSONs, OpenAPI formats, etc., etc. That's why we are using here FastAPI. Those are some references of references of some people, senior developers working at Microsoft, Uber, and Netflix. They said that FastAPI was their most used solution when deploying models or when trying to build APIs quickly from the bottom. Yeah, so we are going to be using it also as a preview here. Let me open the preview. So the preview is from Katana. Okay, so let me reshare my screen. Okay, so 1 minute. So my screen is going to be shared again. Okay. Okay, so here what I'm showing you guys is the Katana interface, which is, as I told you, being built on the top of FastAPI and and Docker. Here, what the Katana team did is that like they tried to create some endpoints, ready to be used. But before this, let me show you just like quickly how to build what is it, to build a quickly a fast API, a very quick API using fast API. So as you can see here, you just need to import fast API, the module fast API. Implements the root. Either it can be get requests or post requests or update requests or delete requests. So good. And then we define the function that's going to be executed when we call this route. Then like the response is going to be returned here. So it's as easy as this. Define importing fast API. Define the root and the method of a request. Either it's a get or post or update. Then just like return your value, and then that's it. So how to run it is just like using the UV-corn module. So it's as easy as doing this. For the Katana here, what they are doing is that they made some pre-done models like the Iris model. I don't know if you know guys about the Iris or the Boston dataset. So the Iris is just a kind of classification model that could classify flowers. Here we have two endpoints. This endpoint is the Iris train model, where we can train models, or we have the Iris predict flower, which is the prediction endpoint. So this is the training endpoint. This is prediction endpoint. We can try the prediction endpoint just by clicking here, try out. So we just give it some parameters. Here are the sepal length, the sepal width, and the petal length and the petal width, which are the dimensions of the flower, by the dimensions of the plant. So here, if I change this from 12 millimeter to 1 millimeter, and here to 10, then here to 7, and here to 2, and then I go here and hit execute, I'm expecting a response. Inside the response, I'm going to be getting the classification of like which type of flower is corresponding to those parameters or corresponding to those values. Here they are telling us that it's Virginica, so this is the classification of those parameters. So this is a classification model that works on machine learning, and that gives us the the Eris prediction. I want to do now. I can just like take this. The IP may have changed. Sorry, no. Let me send it to you. Here is the IP of the project, and let me share with you the GitHub of the project, because it's. Sorry, it's not this one. Yeah, those are the links for the project, for the IP for the project here. So what we can do is just like if I take this IP here deployed on Heroku, yeah, and I go to like /iris and /predict flower, then like it's going to be getting method not allowed, since it's only getting get method. So if I send a get if I send a get request here to this link with those parameters here that I sent here. I don't know if you ever heard about Postman. So you can use Postman to test it on your own. Just get this link with this path or this route. Then you are going and send as a get request, send those parameters. You are going to get a response containing the prediction ID, obviously, and the classification. That's what we want. We want a model running on the background. I just want a link where I can send the what we call the request, the get request, then something is going to be happening in the background. Then I'm expecting on the as an output, I'm expecting the results. You can see here on the project. So this is the Katana project. Let's go to core. Let's go to datasets. So here we have the Eris dataset, which here they are just like loading it. Let's go to scripts. Oh, this is for interesting APIs. More V1. Then here we have the Eris. Okay. So you can see here that they are using FastAPI routing. So API router from FastAPI router. They are initiating an API router. Then they are taken for every route. So here we have /train model route in order to get the to make the training. So here we have a function called Eris train, and inside it we are training. We are just like doing training. And here we have /predict flower, remember? So this is /predict flower. And this is a post request. So this is expecting a post. So we need to send a post request on it. So I'm going to get information. Here, what happens in the background is this function. So what I wanted to state is that it's easy. It's very easy with FastAPI to just like build very quickly an API like this. You can see that it's only on 46 lines of code. Get a router, build a router, define my functions. Those functions you can get them from the your testing Colab or your testing Jupyter Notebook that you were using when testing your model. So you just get those functions, input them down or along with the router method, either post or get or etc. Then you are going to be getting your requests. So it's easy to build this with FastAPI. Now, what's happening, what we did right now, or what we know to do right now, is just like to build the API that's going to be running in the background. But I need to scale up. Remember, I'm deploying for production. I need to have a solution that could be scalable. When I have 1,000 requests, it's going to be working fine. When I have 1 million requests, also it's going to be working fine. When I have 2 million, etc., etc. So it needs to be scalable. It needs to be working on a good basis. Here where Docker comes to help. Here where Docker comes to help. So this is, by the way, an image of DALI when you write Docker. So if you go to DALI and you write Docker, it's going to be giving you this image, which is always wow how DALI is working. But yeah, Docker, as another very quick small introduction about Docker, is that Docker is a virtualization or a containerization solution that helps us to run many applications in parallel without having any conflict of versions or any conflict of dependencies. So imagine that's like the opposite of Docker is a virtual machine. So imagine you have a virtual machine. Virtual machine is just like your own laptop, and you are working on your own laptop on project A. Project A requires on application A. Application A requires. Imagine that you are using Linux. And on Linux, application A requires Java 8 plus Python 3.6. And without those versions, it's not going to be working. Then, when you are done with application A, you want to work on your laptop, when you're on the same laptop, you want to work on application B, running also on Linux. But this application requires Java 12 or Java 11 with Python 3. Or Python 2.7. So those are two versions of two libraries or two tools that they are there's a conflict here and they are complicated to manage. So either app A is going to work and app B is going to fail, or either app B is going to work and app A is going to fail. Either one of them, not both of them. And this is bad on production. Let's say on development you can use virtual environment, something like this. So you can have the solution. But on the production, no, it could not be done like this. Here where Docker is coming to help. So Docker is a virtualization layer that stays on the top of the operating system, and it allows us to run many applications. So as we call them containers, and those containers are going to be running independently of each other. So I run container A independently of container B, also independent of container C, etc. So I can run an application that uses Java 12 with Python, I don't know, with another library, specific library X, and along with app-b that uses the opposite versions, and I can run them in parallel peacefully. That's the power of Docker. Also, there is another power of it, which is like called Kubernetes. It's another technology that allows us to scale up the solution, to be able to manage many requests, to create many duplicates of the same application. Then we can handle 1 million requests, 2 million requests, etc. In parallel in a good amount of time. The Cortana project that I showed you is using FastAPI on to build the functions that they're going to be used on the background, but uses Docker in order to scale and in order to containerize the application. So the application could be deployed and could be used without any interference and could be used without any dependency conflicting or dependency issues. Let me show you the Docker file that is being used. Let's go to the GitHub. Yeah, so any project that is using Docker, you can see that it contains something called Docker file. Here, the Docker file is very simple for the Katana project. So always make it simple. Now here we are using an image. This is what we call the image. Here we are using the Python 3.x image, which means that our container, in each time I'm going to be creating a container from here. Each time I'm going to be creating like here a container. The container is going to be running on the top of Python 3.x image. I don't care about which operating system. I only care that it's going to be containing Python 3.x. Then, what is it? Yeah. Then I'm defining my working directory. It's just like making mkdir or mkdir directory on Linux command. So here I create user src app. Then I copy the requirement. I copy the requirement.txt. Requirement.txt is just a file that contains all the required libraries to run the application. So I copy it to the working directory. Then I install the libraries. Then I launch the bash script called launch.sh. Launch.sh, which is this one, is just going to be launching my application. So what I did now with Docker is that I created a Dockerization container. Sorry, I created the container that is containing the file app.py, the main application. Then, like I created a working directory inside this. So it's like a container is just like a small computer, small virtual machine. So it has its own NFS or its own file systems. So here we have the app.py, the requirements installed. Then I have the script, which is going to be launching the application to be interacting with the internet. So it's like all of this is going to be done automatically and can be duplicated when I use Kubernetes. That's what I mentioned Kubernetes. So I can scale up and scale down the containers and scale down my solution. So to sum up and to summarize what I wanted to show you theoretically today, then on part 2 next week, inshallah, I'm going to be showing you. We are going to be coding. So 1 hour is not enough to do coding. Just like today, what I want you guys to sum up is that I can take my model, my H5 model. I can take the scripts that I test my model on it. I can input it into a FastAPI. Inside FastAPI, then test like the FastAPI locally if it's working, then containerize the whole code of the FastAPI, put it inside a Docker container, and ship that Docker container or deploy that Docker container. So here I can deploy one model very quickly, very easily, and in a, let's say, clean way. That's the cleanest way we can start with right now. Next week, inshallah, we're going to be seeing the application, the practice of this using a real world project. Not like we can use Katana next week, but I just wanted to show you Katana because it's a mix between those two things. It's a framework that mixes between those two things. But I can let you, we can next week try to do this in a small project in practice. We can code this on VS Code. Then we're going to be scaling up a little bit into new technologies, like we can scale up into Kubernetes instead of Docker. Then we can scale into like from Kubernetes, sorry, into another scale, which is the key serve, and so on, so on. Yeah, so I don't know if you have any questions, guys. Please feel free to type them on the chat. We can wait for. Can you send the slides? Sure. 1 minute. Okay, here are the slides on the chat. Any questions, guys? Feel free to type them. Okay, so if no questions, guys, thank you very much for your attention. See you, inshallah, next session about the same topic, but with a new practice. Thank you very much for your attention. See you next week, inshallah. Bye.